Okay, hello everyone, welcome to another live session. Today we are going to discuss about the next part of rational number where we left behind last week. Okay, and we shall start from that part. So it's a brief description so that we can move forward firstly. Okay, let's start. So in the last previous session, if you have not watched, please go and watch. You can get that we have expressed the comparison of two rational numbers, what are rational numbers, and finding rational numbers between two rational numbers, and also the real line representation of rational number. We have all did this. So all are done. Now today's topic is, first topic is decimal representation of rational number. So if I have a rational number like p by q, then if we divide p by q, then I get a decimal expression. Okay. Hello, am I audible? Hello, hello, am I audible? Yes. Now, if I have a rational number like 5 by 2, then it can be written as like this: 2 2 sub 4, remainder 1. Then I am taking the decimal, then there is a 0 put here, and 5. So that's how I can easily get the decimal expression. But there is a twist, that is, if we divide 20 by 3, like 20 by 3 as well, so that will be 6 is 18, again 2, and point, I am taking even as 0, then again 6, 18, 2, up for the point, get a 0, and again 6, 20, sorry, 18, again 2, 0.0, 6, 18, 2, and this is so on. So decimal expression, there are two kind of decimal expression. One is terminating, another is non-terminating, or repeating. Oh, another thing is, in this non-terminating decimal expression, there are two kind of decimal expression, that is repeating, another is non-repeating. Okay, so if I have a decimal expression like this 2.567 and then stop, so after some finite steps the decimal expression ends, then it is called terminating. Terminating decimal expression. Next is, if I write like this, and so on. So there is no end of this decimal expression. So no end of decimal expression. So that will be non-terminating. Okay. Now the topic is, if the expression look like this, 33.33333, so you can see that it is a non-terminating decimal expression. But if you look closely, then you can see that there is a repetition of a digit after the decimal. Okay, so you can also write like this. So which term is repeating simultaneously? So write the term once and do a bar on the above the number. Okay, so this is a repeating terminating decimal because a term is repeating. You can see a pattern, a similar pattern will be repeated in the repeating non-terminating decimal. Okay, repeating decimal expression writing. Okay, next topic is important rule. Important rule: if this is my P by Q are rational expression, and if this divisor is Q, so if when the prime factors of Q are only when the prime factors of Q are only 2 and 5, then P by Q has terminating decimal expression. Then also terminating decimal expression. Some example are 1 by 2, okay, 3 by 4, okay, 7 by 20, okay, also true. 13 by 25, yes, is also true. Another is 5 by 32, yes, it's true. But 11 by 24, there is two kind of prime factors in 24. One is 2, another is 3. So it is not terminating. This is a non-terminating decimal expression. Now my question is to you, without division you just check it. Check whether terminating or non-terminating. Non-terminating decimal expression. Just check it. (27 by 80) and 7 by 9 and 25 by 24. Just check it. So I am giving you some time to the sum. Decimal expression. The prime factors. Okay. So this is a okay. The time is up. Now let me do this. 27 by 80. So in 80 the prime factors only 2 and 5 also. There is no another prime factors. Okay. And so it is terminating. Next is 7 by 9. So here the prime factors are only 3. It is non-terminating. Another one is 25 by 24. So here two kind of prime factors. One is 2 and another is 3. So there is a prime factor except 2 and 5, that is 3 here. So this breaks the rule and it will be non-terminating. Next is repeating decimal expression or recurring also. Next is repeating decimal expression. Okay. A decimal unit, a digit or a set of digits is repeated periodically. A decimal expression where a digit and a set of digits repeats periodically. So we now discuss some example like 2 by 3 here. So if I divide the 2 by 3, first I am taking the point, it will be 0 here, then I am taking 6 and 18, that will be 2 again, that will be 0, another 1, 6 again, 18, 2, and so on. So 2 by 3 is the decimal expression that is repeating, and the repeat digit is 6. So I am just writing the repeating digit only once and mark a bar above the digit which is repeating periodically. Okay, so this is a repeating decimal expression of a rational number. Next, another one, 30 by 11. Twos are 22, 8, taking point, 7, then sorry, 77, then 3, another 0, then again this process will be repeated, then again 2, that will be 20. Okay, okay, okay. I am just writing here. 30 by 11, that will be 2, 22, then 8, I am taking point, and 7, 77, then remainder 3, 0 comes, then again 2, that will be 22, then again 8, point, and again 7. So there is an expression like this, 2.7272727277, and so on. So I am just here, you can see that 72 is repeating periodically. Okay, so the repeating number I am writing only once, that is 72, and mark a bar above the number. Another one is 15 by 7. Okay, 2, 14, 1, 0, 1, 7, again 3, point, 4, 28, 2, 0, 6, again 4.0, 6, 4, 0, then again 5, 35, again 50, 7, 49, 1, again 0. So you can see that this term is repeating here. This term is repeating here. Here you can see this term. So the term will be repeated is just like that. This term will be repeated again. You can, if you not believe me, you can check it out. Again 1, it will be 7, remainder 3, 0, again 4, 28, again 2, 0, 2, 14, 6, 0, 8, 6, 4, 0. Okay, you can get that the repeating term will be like this. Another number will be what? 5, 7. Again the number will be 1, 4, 2, 8, 5, 7. So this is the decimal expression is repeating periodically. So this is the repeating expression, like 15 by 7 will be 2.142857, again 142,857, again 142,857, and so on. So you can see that this term is repeating. So I am the repeating term. I am writing the repeating term the only once and making it bar. This is the bar. Okay. If my decimal expression look like this, like 37.45234, 234, 234, 234, and so on. So the number will be look like this: 4, 5, 2, 3, 4. The repeating term is here only 2, 3, 4, 2, 3, 4, 2, 3, 4. Here I can see. So I am writing this repeating term only once and making it bar. Nothing else. Okay. Repeated number of decimal places in a rational number is called the length of its period. That is, in the repeating term, the length of its period is the number of elements in the periodic repetition. Repeated number of decimal places in a rational number is called the length of its period. Okay, so if I have a decimal expression like 2.147581475 and so on, so I am writing like this 14758, and then I'm taking a bar here. So the number of elements in the repeating period are 1, 2, 3, 4, 5. So length is here 5. Okay, we got it. So always remember that a rational number always two kind of decimal expression. One is terminating, another is repeating or recurring. Decimal expression. Okay, only these two kinds. Always one is terminating, and if it is non terminating, that will be repeating. Now my question is to you: express 3 whole 1 by 8 in decimal. Another is 1 by 7 in decimal. This is question task 2. I am giving you some time. Okay, let's do the sum. This will be some lengthy, but that will be done here. 3 whole 1 by 8. So I have to transform into normal fraction. That will be 25 by 8, and now I have to convert it in decimal expression. So 3 8 are 24. Remainder is 1. Again I am putting point in 0 1 8 2 0 2 16 4 0 5 40. So here you can see the 3 whole 1 by 8 is 3.125. Say terminating decimal expression. And this will happen in the both cases. I have declared it earlier that if a number is rational number, then it has only two kind of decimal expression. Either it is terminating decimal expression or it is repeating or recurring decimal expression. And if any one of these happens, if a number has terminating decimal expression or it has a repeating or recurring decimal expression, then the number will be, of course, rational number. Okay, I am marking it as picking another color here. So that will be, of course, a rational number. One is terminating, another is repeating or recurring. Here you can see that it has a terminating decimal expression. So that is a rational number. Of course, it is a rational number because it can be expressed as P by Q. That is 25 by 8. Here it is integer. Here it is integer. And it is not equal to 0. We have discussed it in the previous video, of what are the expression of a decimal of a rational numbers. Okay, next 1 by 7. Okay, that will be some lengthy, I guess. One by 7. I have to point it in 0 1 7 3.428 again 2 0 2 14 6 0 8 56 4 0 5 35 again 5 0 7 49 1 and 0. Again the repeating term is happening, that is 10 here and here it is also 10 and repeating. Okay, there is another color of this. Okay, so this getting a 10 again, so this term will be repeated again. So number will be 1 by 7 is 0.142857 and so on, because this term will be repeated again. Now the length is here. Okay, below the bar there are 1 2 3 4 5 6 elements, so length of period is 6. Okay. Now this is your task to find this decimal expression, and it is very important. It is important. That is 1/7. Okay. Remember, the period in this sum, the period of length, the length of period will be 16. The term will be 0.88823529411747. I hope it will be very lengthy sum. So this is your home task. Okay. Next thing is if decimal expression is non-terminating and non-repeating, then the number will be irrational number. Okay, we will come into it after some time. Before it, we just do some sum. Now my topic is here that decimal expression to p/q form, then definitely the decimal expression will be 1 is repeating, another is terminating. So a terminating decimal expression you can also convert it to p/q, but the point is what happened to repeating decimal expression. So here it is. Okay, 0.3 bar, convert it to decimal expression. I am converting it. So let x will be this. That means 0.33333 and so many times. So if I multiply 10 with this, then the decimal expression, then the decimal jump into one digit right side. So the number will be 3.33333333 and so on. Okay. Now if I subtract this 10x minus x, the 10x is 3.33333. This is my 10x, and x is 0.333333, so on. So you can see that the decimal portion in these two parts are same. So by differentiation, the decimal portion will be deleted here. Okay, and here 10x minus x means 9x. So x will be 3/9 or 1/3. Okay, I am doing it more expressively, like 3.33333 and so on, and here it is 0.33333 and so on. So if I subtraction. If I do the subtraction, then the decimal part will be deleted because every terms are same and every terms are infinite terms. So infinite one is infinite, that will be deleted. So 3.0000 and so on. So that will be also 3. Remember this to solve. This is a rough work here. Okay. Next another one is convert 1.4 bar into P by Q form. Okay, I am assuming it as the x is 1.4 bar. That means 1.44444 and so on. So if I multiply with 10 digit, the decimal will jump into 1 digit in the right side. So the number will be 14.44444 and so on. Okay. Now if I do the subtraction, 10x minus x, that will be 14.44444 and so on, and here it comes 1.4444. If I do the subtraction here explicitly, that will look like this. So this will be all are cancelled out. So the only the left side of the decimal term will be remaining. The term will be treated as 0 as well. So here you can see the subtraction. This is my 9x plus 13. Then definitely x will be 13 by 9. So my x was this. And this is the P by Q form. So 1.4 bar will be 13 by 9. Here also I am writing that this is my x here in the decimal form and this is x here in the P by Q form. So 0.3 bar will be 1 by 3. This is my answer. Next, my task to you, convert this into standard form or P by Q form. Both are same. First question is 0.9999. This one, and another is 0.57. This is some task to you. You have to do this. I am giving you some time. Okay, let x 0.9999 and so on. I am multiplying it with 10, so that will be 9.99999 and so on. So if I subtract x from 10x, then that will be 9.9999 and so on, and minus 0.9999 so on. So the decimal part will be deleted as well, that will be 9, and here will be 9x. So x is 9.9, it will be 1. This is the standard. Next is .57 bar. Let x, that means 0.57, 57, 57, 57 and so on. So remember, just remember it, the terminating, the period, the length of period is here 2. Okay, the length of period is here 2. So you have to multiply with 100. Okay, how much the length of period, the number of zeros is as much as the length of the period. So 100x will be 57.57, 57, 57 and so on. Now 100x minus x will be 57.57, 57 and so on, that minus 0.57, 57 and so on. Here, notice it, here I am not multiplying with 10, because if I multiply the 10x, the term will be 5.757575. Okay, I cannot subtract because the pattern is not followed as well. Here you can see. Here you can see. Okay, so this is a wrong. So always remember the length of the period. The length of the period is corresponding to number of zeros of after 1. I am multiplying with x. Okay, so that will be 57, and here it is 99. So x is 57 by 99. Okay. Okay. This is my x. So 0.57 is 19 by 33. So this is the decimal expression. This is the p by q expression of the decimal expression. Next is convert it into p by q form. Okay, so I am writing, I am mentioning as a variable to this as well. Okay, so this 4 is not under the bar because it is not repeating. Okay, if it is if it repeats, the number will be shown as like 2.4178, again 178, again 178, because you can see that the 178 is the repeating portion. So you have to just to after the right side decimal, you have to put the only the repeating portion. So at first I am multiplying 10 with x, then that will be 24.178, 178, 178 and so on. Okay, because you cannot put the non-terminating portion right side the decimal. Okay, then you cannot calculate it if you not do this. Now the length of his period is what? 3, 3, 3. So I am multiplying 1000 to 10x. 24, 178.178, 178, 178. So that will be my 10,000x. For 178.178, 178, 178. Okay. So you have to just subtraction. You have to do subtraction between them. One is this, another is this. Okay. So that will be my 24178, 178, 178 and so on, and minus 2417. That will be my 24.178, 178 and so on. So the decimal portion will be deleted, and here it comes as like this. Okay. So that will be my 43142, and here it is 00, 9, 9, 9, 9, 9, 9. So here it goes 24134 9, 9. Okay, that will be my 5, I guess. So you can cut the factors, common factors as well. Okay, so here it goes. This is the p by q form. Two point 4178, 12077, by 4995. Okay. Now this is your question. Convert this to simplest form, that is 2.36 bar plus 0.23 bar. Okay, so sum. Next topic is, that is irrational number. Irrational number. So what are irrational number? Those number is non-terminating and non-recurring decimal expression. Numbers which have non-terminating and non-repeating decimal expression. Example like 0.20, 200, 20002, 00002, 00002, 00002. Okay. Another example I am writing 0.234511876834511666000087 and so on, and it is non-repeating, of course, because there is no pattern or period of repetition. Like root over 2, root over 3, root over 3 plus 7, 3 plus, okay, 7 plus root over 7 also. All of these. Now example of some kind of irrational number, type 1. Clearly 0.1001, 0001, 00001, and this is a non-terminating, non-repeating decimal, therefore it is a rational number. Okay. Next, another type is like if m is a positive integer and m is not a perfect square, then root over m is a irrational number. Always remember this. Okay. Type 3. If m is a positive integer and m is not a perfect cube, then 3 root of m is irrational. Okay. I'm giving some example here. root over 2 because 2 is not a perfect square, root over 7 because 7 is not a perfect square, root over 9 for 9 not, root over 19, okay, root over 8 because 8 is not a perfect square, root over 20 because 20 is not a perfect square. And here some example, cube root of 3, yes, cube root of 9, yes, cube root of 4, yes, cube root of 15, yes, and so on. There are various of irrational numbers. Note that pi is irrational number. Remember, but 22 by 7 is rational number always because it is from the p by q. It is from the p by q, okay, and both are integers and this is not equal to 0, so it is rational number. So why we write pi as 22 by 7? Because to calculate easily we just do the approximate value, that is 22 by 7. Okay, this is approximate value because the decimal expression of pi has non-terminating decimal expression, it is also non-repeating. Okay, next some properties. Properties of irrational number. Okay, this is property number 1, that is irrational numbers satisfy the commutative, associative and distributive laws for addition and multiplication. Irrational numbers satisfy commutativity, associative and distribution law for addition and multiplication. Okay, next property is sum of two irrational number need not to be an irrational number. Like 2 plus 4 plus 2 minus root over, okay, root over 4 I am not, root over 40 say, then definitely that will be 2, so it is rational. Next is a rational number plus or minus an irrational number. Always irrational. Like 2 minus root over 3, irrational. 2 plus root over 17, irrational. Minus 7 by 8 plus root over 55, it is also irrational. Etc. Okay. Product of two irrational may be rational or irrational also. Like if I product root over 7 root over 5 divided by root over 35, it is irrational. But if I multiply root over 7 into root over 7, that will be root over 19 and that will be 7. So that is rational. Next property is quotient of two irrational need not to be an irrational. It may be rational, it may be irrational. Like root over 5, root over 7, that will be root over 5 by root over 7. It is irrational. Like 2 root 3, division root over 3 equals to 2 root 3 by root over 3, that will be 2. It is rational. The quotient is rational. Now an important result. If A and B are two positive rational, then A plus B by 2 is rational, lying between them, A and B, and root over A into B is irrational, lying between A and B. Okay. Now this is your task. That find two rational number lying between root over 2 and root over 3, where root over 2 is 1.41421356 and so on, and root over 3 is 1.732050807. So I am ending here this session. We shall be meet again in another session. So thanking you for joining today's class. Jai Hind.